Hi guys, so this is going to be a short, hopefully, set of notes on 7.1.3, which is sine and cosine graphs with phase shift. Forgive me if my pen makes noises when I write. I think it tends to be a little clickety-clacky, but just bear with me on whatever extra sound you're hearing. So following up on yesterday's lesson, when we learned the sine and cosine parent graphs, we did not have, there was one transformation that we didn't talk about at all, and that was if you have a horizontal shift. So today we're going to be looking at a function with any of the four possible transformations that you could have, reflections, shifts horizontally and vertically, and stretches vertically or horizontally. So I've just kind of tweaked our functions now to include an h. So a value that is adding or subtracting from your x variable inside the function versus outside the function. And I have a little mistake right here, so I'm just going to fix that on the sine one. Those brackets were should not be around the k. So everything the same in those equations, except now we have this k that's inside with our x, also being affected by our b right there. So it's the h that we're focusing on today. So we know from past units and years that when we have something adding or subtracting inside our function with our x variable, that it causes a horizontal shift. When we talk about sine and cosine graphs, we give that a special name. It's called the phase shift. So when we say phase shift, we're just talking about horizontal shift. Now, we typically kind of leave this as its own lesson, just because when you start to shift a sine or cosine graph, it can get confusing because they're cyclical. So if you shift a sine graph, then it may just end up looking like a cosine graph and like kind of mapping back onto itself. So it can get a little bit confusing, and that's why I like to put it on its own day. But it should still be pretty brief as we go through this. So we'll start same way we did yesterday. We have we're going to be graphing y equals 3 sine of 2 times x minus pi over 4. And I'll just encourage you to pause at any point and just do this with me. So go ahead and start by just doing a quick pause and jotting down what you see as the period. Always want to identify the period, the amplitude, the midline, and now the phase shift, which I'll write out here, but from here on out I'll just call PS phase shift. So go ahead and figure out what those would be, and I will go ahead and assume that you've unpaused. So our period here will be 2 pi over b. Just going through this equation, I'm going to identify the 3 as our a, the 2 as our b, and the pi over 4 as our h, because it's inside it's inside with the x, not outside. That would be where a k would go. We don't have a k here, so we have amplitude. A period is going to be 2 pi over 2, because that is our b, which gives us pi. Our amplitude is the absolute value of a, so that'll be 3. Our midline, I'm going to be really careful to say y equals 0. I have no k value. I can think of that k as being 0, and we say y equals to show that it's the horizontal line at 0. And then our phase shift, I've got h is pi over 4. Now, just keep in mind, phase shift is like any other horizontal shift. It's like the opposite of what we see there. It's minus h, not plus h. So in this case, my h would be pi over 4. And because it's minus pi over 4. If it was plus pi over 4, it'd be negative pi over 4. And then what I'm saying there is I'm shifting to the right pi over 4. So this function is getting shifted to the right. Okay, so I have a graph that I've labeled already. You're going to be graphing on Desmos, so you're going to already have a grid labeled, x-axis and y-axis labeled. So I'm going to go ahead and start graphing. I've identified all my things. Now I'm going to start worrying about how I show that on the graph. The thing that I'm going to suggest you do is identify the window of your first period. So first period, I'm going to say window. So what I mean by that is from where to where is your first period going to be graphed. So when we shift, I'm no longer starting at x equals 0. I'm going to be starting at a different x value. So I know that because I have shifted to the right pi over 4, that's where I'm going to start. I'm going to do an interval here. So when I use this bracket, I'm saying like from somewhere to somewhere. Hopefully you remember interval notation. So I'm going to put pi over 4 first because that's my phase shift. I'm going to be starting my first period at pi over 4. I better add that to my graph. My graph goes by pi over 2's. So pi over 4 would be half of pi over 2. I'll divide this whole thing up into pi over 4's. And then I want to know where is that first period going to end. And the reason that I'm doing it this way is because if we shift over, then you don't get to just find that value pi on the x-axis and say, okay, well that's the end of my period, right? Because if I've shifted, then that pi isn't where the period ends. It's that pi represents how long the period is. So I need to go pi units from pi over 4. So I always want you to kind of jot down where that period will end. And the way we do that is we say, okay, well, if I start at pi over 4 and I add pi, what do I get? So pi over 4 plus pi, going to get common denominator there. So pi over 4 plus 4 pi over 4 is 5 pi over 4. So read this as from pi over 4 to 5 pi over 4. That will be the window of my first period. So I'm going to go ahead and just kind of block out that window. So I'm going to draw a line here at pi over 4. And you can draw that or not draw it, but I'm just trying to show you. And then 5 pi over 4, I'm just going to count out 1 pi over 4, 2 pi over 4, 3 pi over 4, 1, 2, 3, 4, 5. This is 5 pi over 4 if you want to get this all labeled. And you can use your unit circle for help there if you're struggling with the fraction aspect of it. So there's 5 pi over 4, so then that is where my first period should end. Some people tend to be confused here because the period is pi, so why am I not ending at pi? Well, because I've shifted to the right. So if I shifted my beginning right pi over 4, then my end is also shifted right pi over 4. Okay, now that I have that blocked out, I can keep in mind like what needs to be shown within one period. So I'm going to start with what am I graphing? I am graphing sine. Sine, I know, starts on the midline. You can refer to your notes from yesterday. Sine always starts on the midline. I do not have any kind of shift, so I don't need to necessarily draw my midline because it's just going to be the x-axis. That's why I haven't talked about that. So I'm going to start on the midline, but I've shifted over. So this is now my starting point. So starting from pi over 4 instead of starting from 0, but starting on the midline because it's sine. And then I know that I'm always going to plot my last point in the first period next. So my next point that I would plot is right here at 5 pi over 4. It's much easier to plot the first point and then the last point and then fill in the points in between because you're no longer just going to where whatever your period is and plot and that's where you need to end. I've determined my window so that I can still plot my first and my last, and then I need to divide that space up into 4 equal parts. Now that's already kind of done, right? So if it wasn't already done, I would kind of divide in half and then in half again, because within any one period there are 5 key points equally spaced. So beginning, and then end, and then divide that up into fourths, and you're going to have a point at each of those lines. I already have those lines kind of shown on here, so I can go ahead and start graphing. So my amplitude is 3, so I'm going to go up to 3 at pi over 2. My next place that I'll plot a point is at 3 pi over 4, so back to the midline, and back down to my minimum, and that would be, you could call this your first period because this is, if you're thinking of the beginning as 0, this is shifted over, so this is my new beginning point. But ultimately, it doesn't matter like where the first period is. This function continues on, but the first period helps you get the pattern of it, and then you can draw in everything else. Oops. Okay, so that's how I would graph this sine function. I'm going to do one more on the next page. Feel free again to pause at any point so that you can try to start it yourself. So I'm going to go ahead and start. Now, if you did pause and start this problem, it's likely that you made a mistake. So I'm going to just refer back here. I'm looking for an equation to be in this form. If you look really carefully at this and compare it to this, you're going to see that it doesn't really match up. And that's because of the way that we need this to be written for us to identify correctly what B and H are. So if you look at how we need this to be written for identifying H, we need what the cosine is of, so this part in brackets, we need it to be factored. So I'm looking here and I'm not seeing that. So you'll see that the B has been essentially like distributed in. That's why we don't see parentheses here, is because the B has been distributed in. If that's the case, this is not your H. This is the H with the B multiplied into it. We have to unmultiply that B and get it written how it really should be. So we need to factor out our B from this binomial so that it really matches up with the form of the equation that allows us to identify all those variables. So what I'm going to do is I'm going to factor out 2 from each of those two terms. Obviously the first term is easy to do. I factor 2 out of 2x and I get x. And then if I'm dividing 2 pi over 3 by 2, it's the same as multiplying 2 pi over 3 by a half. I'm going to just kind of show that what I'm saying there. If I need to divide 2 pi over 3 by 2, that's the same as multiplying by a half. Okay, so I'm factoring it out, dividing by 2. Dividing by 2 is the same as multiplying by the reciprocal. So that's going to get me 2 pi over 6, which is the same as pi over 3. So I've factored out the 2. Now you can check this, and you should check to make sure that this still gives you what you had above. So if I were to distribute that 2 back in, then I would get what I have above. So that means I haven't done anything wrong. I haven't done anything that's changed the function, but now it's written in the correct form. So now I'm going to be correctly identifying my H. So this is not our H. Now that it's written factored, this is my H. Okay, everything else you would have gotten right. It's the H that you would have gotten wrong if you forget to factor. So I'll go ahead and jot down. I have a period. Also, I always start with period because it's kind of the most important one. So my period is going to be 2 pi over 2, because that's my B, which is pi. Is this the same as the last one? That's not super exciting. Yeah, they're the same. Well, anyway, period is pi again. Amplitude is going to be the absolute value of A, which in this case is -2, so 2. I have a phase shift, I'm going to say PS, of negative pi over 3. That means I'm shifting to the left pi over 3. Again, negative because it's the opposite here. And then I have a midline that has been changed because I have this -1. Shifting us down 1, so my midline will be at y equals -1. So jotting down those 4 things, and then I'm always going to get that first period window. So I know that my first period is going to start at negative pi over 3 and end at, and again, how I figure this out is it's going to end pi units away from where I start. So negative pi over 3 plus pi. I'm adding pi because that's my period. I'm not always going to add pi. I'm adding pi because that's the period. And these two happen to have the same period. So these two, I was adding pi to both of them. But again, that may change. Okay, so that tells me that my first period is going to be graphed from negative pi over 3 to 2 pi over 3. And that'll be my first period window. So I'll draw a line to remember, to remind myself of that. Negative pi over 3 and 2 pi over 3. Okay, now I can start worrying about graphing. So I have a midline that is not 0, so I'm going to start by drawing that in. Y equals -1 is my midline. I need to label off my x-axis or my y-axis a little bit. So y equals -1 is my midline. And I am graphing cosine with a amplitude of 2 and a reflection because I have a negative that's in front. So I'm going to start off the midline. So cosine starts off the midline. I would normally start up 2 with an amplitude of 2, but because this is a reflected graph, I'm going to start down 2 from the midline. Now, I'm not going to start here, though, because I have my phase shift, and that's why I drew this line so that I could remind myself that I'm not starting at 0. I'm starting on this line at -π/3. So here will be my first point. -π/3 because that's my phase shift, so I've shifted over from 0, and down at -3 on the y because it's an amplitude of 2, and it's been reflected, so I'm starting below my midline. Okay, and then think about where I would say to plot the next point. I would always say to plot the next point, plot your last point in that period. And that's where I would end. Now, I have a problem here with the graph that I gave myself and that, let's assume, has been given to us, is that this graph has been divided up in terms of π/3. But I did this on purpose so that you would see that we have to make sure that we equally space our points in between. And remember, there's always going to be 3 points in between. They have to be equally spaced every time, and there should be 3 points in between the first and the last. There should be 5 key points on every full period. Now, the problem that I've created for myself is this is not divided up into fourths like the last one was. That one was already kind of naturally divided into fourths. This one is not. It's divided into thirds. So I'm going to have to adjust how this is divided up. So bear with me, because what I'm going to do here is I'm going to divide each of these thirds into fourths. If I want to divide thirds into fourths, I kind of have to go into twelfths is what I'm doing here. So I'm taking each of my thirds and dividing it up into fourths, so that now I have 12 little spaces in between my 2 blue lines, and that way I can definitely find halfway. And so that's a value, a number that I can divide in half and in half again, because that's what I have to do. I have to find the halfway point, which would be right here, and then the halfway point again. So now I've evenly and accurately divided up my graph into 4 equal parts, or my period into 4 equal parts, and that's where my points will go. So I'm going to go point on the midline right here, that one little hash mark over, and so every 3 of these minor lines I'm going to be plotting a point. My next point is going to be up 2 from the midline, so that's going to be right there at y equals 1, and then back to the midline at this little hash mark right there. And so you can see I'm placing points at every 3 of these minor lines. Most likely your Desmos activity will already have minor lines drawn for you, but I had to do that for myself. And I can't just kind of willy-nilly plot these points. I want them to be accurately placed. And so now I can draw in my graph. So that's the same thing we did yesterday with the added aspect of phase shift. And I really want to encourage you to do this step, because that way you're going to make sure that you graph the whole period, and you're correctly knowing where to start that period and where to end it, and then hopefully equally spacing the space in between and making sure that you account for those other 3 points. Okay, that's phase shift. Your homework tonight is going to be a Desmos activity, or your classwork. Hopefully you're going to start it in class right now, and I'll see you tomorrow.